All right, in 4.4a, we're going to be solving exponential and logarithmic equations. A and B are pretty much the same. I'm just going to split it up into two videos because there's a lot of examples. All right, so here we go. We're going to solve the exponential equation. There's two strategies that you can choose from. I'm fine with either way. It doesn't matter to me which one you choose. One may make more sense to you than others. Okay, so for example 1 right here, the strategy 1 would be to get the same base on either side of the equal sign. Okay, 4 is the base on the left, so I'm going to leave it, and I can rewrite 16 as 4 squared. And once the bases match, they drop out and the exponents drop down, so x is equal to 2. There you go, that's all you got to do. Now the other strategy is to rewrite this as a logarithm. So as a logarithm, base 4 of 16 is equal to x. Now you can put this in your calculator like this. Let me show you. In your calculator, you're going to go to Math, and if you scroll all the way down to A, it says log base. And you can type that in, log base 4 of 16, and you get 2. Either way you work it is fine. So I get x equals 2 both ways. All right, so number 2, let's do the same thing. We're going to rewrite this as a base with the same basis. So 5 to the x. Now, hopefully you know that 125 is 5 to the third. So I can rewrite this as 5 to the negative 3 power. So x is equal to negative 3. Or I could rewrite this as a logarithm. So log base 5 of 125 equals x. And I won't show you the calculator because you can do this in class, but when you do that, you're going to get x equals negative 3. All right, let's try example 4. Same deal. We could start by rewriting it at the same base of 8. So 8 to the negative 1 to the x power is equal to 8 squared. So when you raise an exponent to a power, you multiply. So this is 8 to the negative 1x power equals 8 squared. Bases drop out because they match. And I have negative x equals 2, which means x is equal to negative 2. Or I can rewrite this as a logarithm. The logarithm of 1/8 of 64 is x. I put that in my calculator, and I get x is equal to negative 2. Both ways work. All right? Now, what about if the base is e? Or rewrite this as a logarithm. So x is equal to the log base e of 14. All right? So we know a log base e is the natural log. So all I have to do in my calculator is find out what is the natural log of 14. So I go natural log of 14, and there's my answer, 2. All right. Now there's really not another strategy with that one. It's pretty straightforward, so ignore that. You don't really need that one. All right, number 6. Okay, 2 strategies possible on this one as well. So to get them to the same base. So what I have to realize is this. 2 over 3 to the x power is, and over here, this is 3 to the 4th, and this is 2 to the 4th. If I flip this, this would make a little bit more sense and be a little bit more usable. Okay? Or I could write this as 3 halves to the 4th. But I need to flip it over so it matches the base on the left. So what I do is 2/3 to the x power. And to flip it, I just make it a negative 4. That's all you got to do. Once the bases are the same, the bases go away, and x is equal to negative 4. Now, I could just rewrite this as a logarithm and say the log base 2/3 of 81/16 equals x. It's a little cumbersome to put in my calculator, but I still get negative 4 when I do that. Okay. Now, what about number 7 here? First strategy, like we've done before, is rewrite these with the same basis. So I'm going to leave 2 to the x plus 3 power equals 2 to what power is 256? Well, maybe you know your powers, maybe you don't. So 2 squared is 4, 2 cubed is 8, 2 to the 4th is 16, 2 to the 5th is 32, 2 to the 6th is 64, 2 to the 7th is 128, and 2 to the 8th is 256. So that's the one I need. So I'm going to rewrite this as 2 to the 8th power. Now, the bases are the same, so the bases drop out, and I'll have x plus 3 equals 8. Now we're back to basic algebra. So x is equal to 5. Or you could just rewrite this as this power coming out to the front. Usually it's an x, right? Well, it's going to be x plus 3 equals the log base 2 of 256, okay? So I'm going to put log base 2 of 256 in the calculator. Math, go down to A. And I get 8. Okay? So now I have x plus 3 equals 8, so x is equal to 5. Either method works. Whatever floats your boat. Do the one that works for you. All right, so looking at the next one, we're going to use some natural logs here on this one. So I would solve the logarithmic by making it an exponential, remembering what my base is. If it's a natural log, my base is e, so I'm going to swirl this out. So e to the negative 9th is equal to x. So I put that in my calculator. E is up here, it's the blue one under natural log, so second natural log up to the negative 9th power, and I get this giant number. Now, pay attention, because do you see the e to the negative 4 over here? So don't put your answer as 1.23 times e to the negative 4. You need to clarify that and write it out correctly. So although the calculator does say that x equals 1.234 times 10 to the negative 4, this is not the way you leave it. You put it as 0.00012. This is the acceptable answer, okay? Okay, on 9, there's actually 2 strategies. So I'm going to show you 2 strategies. Here's strategy 1, here's strategy 2. So the first one that I would do, log base x of 625 equals 4, is to swirl this out of the logarithm. So x to the 4th is equal to 625, all right? So I need to figure out, okay, what to the 4th power is 625? Well, my 5's a clue. 5 times 5 is 25. 5 cubed is 125. 5 to the 4th is 625. So I can rewrite this as 5 to the 4th. Now notice my bases are not the same, but my exponents are. So that means the bases are equal. So x is equal to 5. There's one way to solve this. Another way to solve this from this step right here is to take the reciprocal power. So to get rid of x to the 4th, I would need to raise it to the 1/4 power. And what I do to one side, I have to do to the other. So this cancels out, and x is what's left. And so this is asking me here to do the 4th root of 625. Well, in my calculator, here's what I would do. Math, go right here where it says 5, and you can put in the root you want. I want to the 4th root of 625, and it gives me 5 right there. All right, so that's just another way of working the same problem. So number 10, I need to get the logarithm solved. So to get it, I need to get it out of logarithmic form into exponential. So I'm going to swirl it. 11 to the negative 1 is equal to x. That is 1 over 11. And you can leave your answer like this. I'm perfectly content with that. Or if you want to make it a decimal, that's fine. Round it to 3 places. That's okay. On 11, to get the logarithm solved, I need to get rid of the logarithm. The way to get rid of the logarithm is to swirl it using the correct base. If it's a natural log, the base is e, so I swirl it. So I say e to the 5th is equal to 2x minus 1. All right, so then I just solve algebraically. I say e to the 5th plus 1 is equal to 2x. then divide both sides by 2. So in my calculator, I'm going to put in e to the 5th plus 1 in parentheses, then divide by 2, and see what I get. E to the 5th. So 3 decimals, 74.707. All right, using this. All right, so we're still solving logarithms, and we need to, they're logarithms, so we're going to probably have to make them exponentials. Now, what's different on 12 is that we have 2 terms, and we need to consolidate these 2 terms. All right, so what I would recommend, there's 2 ways to do this. First of all, here's strategy 1. Natural log of x minus the natural log of 5 equals 0. Well, since it equals 0, I can move this whole piece over here. So I'll have the natural log of x equals the natural log of 5. Well, if you remember one of our properties, if the logarithm is the same in the same base, they cancel out. And so I just get x equals 5. Okay. Another way to solve the same problem is to use our condensing rules. So we know that we can condense this to x over 5 equals 0. All right, and then I would swirl it. So if it's e to the 0 equals x over 5, so that's 1 equals x over 5, 1 over 1, then I would cross multiply or multiply both sides by 5, however you wish to solve this, and you get x is equal to 5. Either method is acceptable. All right, on 13, I'm simplifying. Okay, I can't do a whole lot to this, but since I have a natural log of e raised to a power, this whole expression right here, natural log of e, cancels one another out, and the exponent drops down, and that's my answer. That's all I have to do. All right, 14 says to simplify again. Notice that it's e raised to a natural log of something. So again, it's the natural log and e hanging out together. They cancel out, and the exponent drops down. So it's x squared minus 3, and that's all I can do with that. It's simple enough. All right, look at 15. Look what I can simplify. Natural log of e simplifies out. The exponent drops down. So I have negative 1 plus 2x. I cannot combine like terms, so I'm done. See enough. Last but not least, for 4.4a, let's do this again, okay? So let's take a look at the logarithm here. That e to the raised to a natural log cancels out. So I have 5 minus x squared plus 1. Distribute out the negative 1. Combine like terms. So I have 5 minus 1 is 4 minus x squared. And that's all I can do as far as simplifying it. All right? So that can get you started solving exponential and logarithms. 4.4b has a bunch more examples, so we'll look at those tomorrow night.